Welcome, ladies and gentlemen, to the MC Podcast. I'm Rushton, here today to talk a little science. My partner Chris Stewart is not here today, but it's alright. It should be a wonderful show. Today on the show, I'm going to be talking about science. I will be covering three topics today, which are the law of reflection, the refraction of sound, and the refraction of light. First off, I will be covering the law of reflection. The law of reflection simply states that the angle of reflection always equals the angle of incidence. The diagram right here illustrates the law of reflection. In the diagram, the ray of light approaching the mirror is known as the incident ray, which is labeled I in the diagram. The ray of light which leaves the mirror is known as the reflected ray, which is labeled R in the diagram. At the point of incidence where the ray strikes the mirror, a line can be drawn perpendicular to the surface of the mirror. This line is known as the normal line, which is labeled N in the diagram. The normal line divides the angle between the incident ray and reflected ray into two equal angles. The angle between the incident ray and the normal is known as the angle of incidence. The angle between the reflected ray and the normal is known as the angle of reflection. If you were to sight along a line at a different location than the image location, it would be impossible for a ray of light to come from the object, reflect off the mirror, and travel to your eye. Only when you sight at the image does light from the object reflect off the mirror and travel to your eye. For example, in diagram A, the eye is sighting along a line at a position above the actual image location. For light from the object to reflect off the mirror and travel to your eye, the light would have to reflect in such a way that the angle of incidence is less than the angle of reflection. In diagram B, the eye is sighting along a line at a position below the actual image location. In this case, for light from the object to reflect off the mirror and travel to the eye, the light would have to reflect in such a way that the angle of incidence is more than the angle of reflection. Suppose you are camping on the shore of a lake which is not too wide, maybe a half a mile across. During the day, you can see campers on the other side of the lake, but you cannot hear them. At night, however, you can not only see the campers, but you can also hear their conversations. This is due to the refraction of sound waves. Refraction of sound waves involve a change in the direction of waves as they pass from one medium to another. Refraction is accompanied by a change in speed and wavelength of the waves, so if the medium is changed, the speed of waves are changed. Refraction is considered as a very important phenomenon for the transmission of sound waves from one origin to another. The sound waves come when air above the earth is warmer to the air on the earth's surface. In this situation, sound will be bent back downward toward the surface of the earth because of refraction of sound waves. The next and final topic is refraction of light. When light passes from a less dense to a more dense substance, the light is refracted towards normal. A demonstration of refraction can be performed at home in a dark room. All that is needed is a flashlight, a clear glass filled with water, and a small mirror. For figure A, shine the light directly into the glass. If the light strikes the water straight on, no bending occurs, and it simply passes directly into the water undisturbed, leaving only a straight beam of light all the way to the bottom of the glass. For figure B, shine the light into the glass at an angle. As the light enters the water, it is refracted. Since the light is passing from air into water, it is bent towards the normal. The beam of light would appear to bend at the surface of the water. For figure C, place the mirror at the bottom of the glass of water and again shine the light into the glass of water at an angle. As light initially enters the water, it is refracted as in figure B and then reflected off the mirror. Upon exiting the water, the light is bent away from normal as it passes from water and into the air. The light will leave the flashlight, bend at the surface of the water, reflect off the mirror at the bottom of the glass, and move towards the surface where it would bend outward at the same angle it bent in on the way in. Some history with refraction goes way back to a guy by the name of Willibrord Snell. Snell's law is a formula used to describe the relationship between the angles of incidence and refraction when referring to light or other waves passing through a boundary between water and glass. The law says that the ratio of sines of the angles of incidence and of refraction is a constant that depends on the media. I want to thank everyone for listening to my podcast. That's all I have for today, and I'll see you next time.
Company, always on the run. Destiny